Okay, we're gonna work using Pythagorean theorem to find missing sides of right triangles. The formula for the Pythagorean theorem is this one: c squared equals a squared plus b squared. It's always like that. And the c is called the hypotenuse. It's always the diagonal side, the one that is opposite to the 90 degrees angle. The a will be this height and the b will be this base. So let's try solving this exercise. Okay, find the missing side. Okay, what are you gonna do? Okay, you begin with the normal formula: c squared equals a squared plus b squared. Okay, and then we change the information. Which value is c? C, remember, is the diagonal, so c will be x. Okay, which number is a? A is 3. And which number is b? B is 4. So that's basically what I have to do. Then 3 squared plus 4 squared, if I do that, we'll get the answer 25. Okay, and with that answer of 25, what am I gonna do? The tiny square that is in here, I'm gonna move it to the other side. I'm gonna pass it to the other side, and it's going to turn into a square root. Okay, exponent 2 transforms into square root on the other side, and square root of 25 is going to give me x equals 5. That will be the answer for this exercise. Okay, so x in this case will be 5. Let's do another one. Okay, this one, I need to find x that is in this side. So remember, I need to use the formula of Pythagorean theorem. Okay, now what am I going to do with this formula? Well, I'm going to change the letters. Remember, c is the hypotenuse, the diagonal. So instead of c, I'm going to put 29. A is the height, so instead of a, I'm going to put 20. And b is the base. Instead of b, I'm going to put x. Okay, now my goal is to find x. So in order to find x, I need to leave it alone. So this positive 20 squared, I'm going to move it to the other side, and it's going to transform into a negative 20 squared. Okay, so it will be something like this. Okay, I move the positive 20, okay, to the other side, to the left side, and from positive is going to turn into negative. Okay, now I need to do this operation: 29 squared minus 20 squared. 29 squared minus 20 squared gives me 441. Okay, so I will get 441 equals x squared. Remember, the exponent 2 is going to pass to the other side, to the left side in this case, as a square root. So instead of a square on the right side, I'm going to get a square root on the left side. Okay, so I don't see any exponent 2 because I moved it to the left, and now I have a square root. Square root of 441 will give me 21. So the answer will be that 21 is x. I'm going to write this thing in the opposite order, okay, to explain that x is 21. And that will be the answer. Okay, that's how you solve this exercise. Let's go with the other one. Okay, we have 13 x on the height and 12 on the base. So the formula for Pythagorean theorem is c squared equals a squared plus b squared. Which number is c? The hypotenuse. Which number is the hypotenuse? The hypotenuse is 13 because it's the diagonal. Which one is the height? The height will be x. And which one is the base? The base will be 12. Okay, now I'm trying to leave the x squared alone in order to find x. So this positive 12, I'm going to move it to the other side, but it's going to move as a negative 12. Okay, so I have 13 squared minus 12 squared. The answer for 13 squared minus 12 squared will be 25. Okay. Now what do I do with that 25? Okay, the exponent 2 of the x is going to move to the left and it's going to transform into a square root. Okay, from a square I'm going to get a square root. Square root of 25 is 5. So I get the 5 will be x. Because 5 is x, I'm going to write it the other way. X equals 5, and that will be the answer for this exercise. That's how we solve exercises with Pythagorean theorem. Now the exercises, they may be a little bit different. Like you could have a triangle like this one, okay, which you always need to identify which is the hypotenuse. The hypotenuse will still be 13 because it's the diagonal that is opposite to the 90 degrees angle. If this thing is shown this way, it's gonna look like if the 13 is the base, but not that 13 is the hypotenuse still, because it's always opposite to the 90 degrees angle. So in this case 13 is still C, okay, and I still have x as A and 12 as B. It doesn't matter how the triangle is presented. You need to be careful of always finding the right information for it. That's how we solve exercises with Pythagorean theorem.